Hello there, and welcome back to Non Name Talks.
It's great to be here.
Welcome back to the deep dive. So, I want to start today with a question that might sound a little ridiculous at first.
Okay, I'm ready.
Have you ever felt like you're essentially just a complex houseplant with anxiety?
You know, that is a surprisingly accurate biological assessment.
I had a feeling you'd say that. I've been feeling it lately, that sense that if I just had a little more water and a sunny window, I wouldn't be so stressed.
Right.
But seriously, today we're tackling a topic that feels deceptively simple. The sun. And I know what you're probably thinking. Okay, great. They're going to tell me to go get a tan.
No, not at all. This is not about dermatology. It's about neurobiology and psychiatry.
Exactly. We're looking at a really interesting mix of sources. We've got this huge 10-year longitudinal study on office workers in Thailand, a nationwide survey on depression, and then some really dense papers from places like Johns Hopkins. And the common thread seems to be that the sun is basically the remote control for our sanity.
That's a perfect way to frame it. We're really investigating a modern paradox. We have built this world that's incredibly comfortable. We're protected from the elements.
Yeah.
But that protection has disconnected us from our primary biological timekeeper. And researchers are starting to call the result urban hibernation.
Urban hibernation. That sounds kind of cozy, but I have a feeling the side effects aren't great.
They really aren't.
Yeah.
We're seeing a decline in mental health that, well, it correlates very strongly with this disconnection.
Okay, so let's start with the hardware, because I think most people assume that sunlight feels good just because, well, it's warm, it's bright, it's a nice day.
The vibes, right.
Yeah, the vibes. But the sources are suggesting there is a hardwired mechanism here.
Absolutely. It's not about feeling warm. It's about signaling. One of the key papers we looked at describes sunlight as a biological Zeitgeber.
A Zeitgeber. I love that word. It sounds like a villain in a time travel movie.
It does, doesn't it? It's actually German for time giver. In biology, a Zeitgeber is any external cue that resets your internal body clock. And sunlight is the most powerful one we have.
Okay.
But here's the kicker. This signal doesn't come through your conscious vision. You don't have to see the pretty sunset to get the effect.
Wait, so if it's not about seeing, how does the signal get in? I thought the eyes were just for vision, rods and cones, shapes and colors.
That is what we all learned in school. But relatively recently, scientists discovered a completely different type of cell in the retina. They're called intrinsically photosensitive retinal ganglion cells.
Okay, that's a mouthful. IPRGCs.
IPRGCs, yes. But just think of them as the blue light detectors. They contain a specific pigment called melanopsin.
Melanopsin.
And these cells, they don't care about shapes or motion. They're specifically tuned to detect blue light, right around the 480 nanometer wavelength.
So they're like little light meters built into the back of my eye.
Exactly. And when they detect that specific frequency of blue light, which is abundant in morning sunlight, they send a hardline signal straight to a part of the brain called the suprachiasmatic nucleus.
The famous master clock.
The master clock.
Yeah.
And this is where the magic happens. When the SCN gets that morning light signal, it starts a chemical handover. First, it suppresses melatonin.
Which is the sleep hormone.
Right, it clears the fog. But simultaneously, it triggers the production of serotonin.
And serotonin is the feel-good neurotransmitter. It's what a lot of antidepressants target.
Correct. It regulates mood, focus, calmness. So morning sunlight isn't just waking you up. It is chemically shifting your brain from sleep mode to happy, focused mode.
A literal chemical switch. But what I found fascinating from the notes is that this is a two-way street. It's not just about the morning, is it?
No, and this is where people get in trouble. The sources really emphasize that this is a rhythmic cycle. You need that spike of serotonin in the morning because later in the evening when it gets dark, your body converts that serotonin into melatonin.
Oh, that is a huge distinction. I always thought they were just two separate things. You have your sleep bucket and your wake bucket. But you're saying serotonin is the actual raw material for melatonin.
Precisely. If you don't build up your serotonin reserves during the day with sunlight, you physically might not have enough raw ingredients to manufacture the melatonin you need for sleep.
So by staying indoors all day, I'm essentially sabotaging my sleep 12 hours in advance.
You're breaking the supply chain.
Yes. That explains a lot. But let's go deeper, because there's another molecule here that we usually just associate with milk commercials, vitamin D.
Right.
And the sources were pretty aggressive about redefining what vitamin D actually is.
They were. We tend to think of it as, a nutrient for strong bones. But one of the papers explicitly refers to vitamin D as a steroid prohormone.
Whoa, okay, hang on. Steroid prohormone. That sounds pretty intense. Is it actually a steroid?
Structurally, yes. And prohormone just means it's a precursor. It turns into a hormone in the body. And unlike a vitamin, which you have to eat, your body manufactures vitamin D
Right, from the sun.
from the sun. When UVB rays hit your skin, a form of cholesterol starts this whole transformation process in the liver and kidneys.
So we're essentially walking solar panels synthesizing hormones. But why does a steroid prohormone matter for my mood? What's it doing in my brain?
This was one of the most surprising parts of the research for me. Scientists have found vitamin D receptors, VDRs, scattered throughout the human brain.
Okay.
And they're just in random spots. They're clustered in the hippocampus, the prefrontal cortex, and the amygdala.
The amygdala, that's the fear center, the fight or flight button.
Exactly.
Yeah.
And the hippocampus manages memory and emotional regulation. The fact that these areas are just studded with receptors for vitamin D implies it's critical for how they operate.
So there's a direct link to serotonin here.
A very direct link.
Yeah.
It involves an enzyme called tryptophan hydroxylase, or TPH. Think of TPH as the factory manager. Its job is to take tryptophan, which you get from food like turkey or eggs, and convert it into serotonin.
Okay, so TPH is the worker on the assembly line building the happy chemical.
Right. But here is the catch. Vitamin D is what regulates the gene for TPH. It tells the factory manager to get to work. If you're deficient in vitamin D, that enzyme gets downregulated.
So you could be eating all the right foods, but if you don't have the vitamin D to authorize the production, the factory just shuts down.
That's a great way to put it. You end up with a supply chain crisis in your brain. No manager, no serotonin, low mood.
It's really looking less like a vitamin and more like a required system update for the brain to even function.
Yes. And to see what happens when you miss that update on a massive scale, we have to look at our case study, this fascinating longitudinal study from Thailand.
The EGA study, yeah, this followed employees of the Electricity Generating Authority of Thailand for 10 years.
2009 to 2019.
But before we get into the results, we have to talk about the geography. Thailand is tropical.
Extremely tropical.
The UV index there regularly hits 11 or 12, which is classified as extreme. You can burn in minutes. So you'd assume nobody in Thailand could possibly be vitamin D deficient.
You would absolutely think so. It's the perfect natural laboratory. If anyone should have optimal levels, it's these folks. But the data showed this fascinating paradox.
Right. So over the 10 years, vitamin D levels did go up overall by about 15%, which sounds good.
It does sound good, and it was likely due to some successful health campaigns. But when they peeled back the layers and looked at gender, a massive gap appeared.
A gap.
The improvement was driven almost entirely by men. The women in the study showed significantly less improvement.
Why? I mean, they're in the same offices, same city. Is it biological?
No, it seems to be entirely behavioral and cultural. The sources point to what they call the whitening trap.
Ah, the beauty standard.
Exactly. In Thailand and many parts of Asia, there's a strong cultural preference for pale skin. It's associated with status and beauty. So, despite the sun being everywhere, women are socially conditioned to avoid it.
Umbrellas, long sleeves, heavy sunblock.
All of it. Avoiding the outdoors entirely. So you have a situation where the cultural software is overriding the biological hardware.
The behavior is blocking the resource.
And it's not just vanity. We have to be fair. Living in a UV index of 12 is physically punishing. It's hot, it's humid, so people flee indoors to air-conditioned spaces.
Which brings us right back to urban hibernation. And this isn't just a Thai problem, is it? I mean, I live nowhere near the tropics, but I also spend my life moving from a climate-controlled house to a car to an office.
It's absolutely a global issue. The Thai study just highlights it because the contrast is so stark. But the mechanism is the same everywhere. We spend an estimated 90% of our lives indoors.
Wow.
And one of the sources points out that working in windowless environments has measurable physiological costs.
They mentioned recovery from stress, right?
Yes. They found that people in windowless offices not only had lower sleep quality, but actually recovered from stress more slowly than those with a view.
That is profound. If you have a bad meeting and you're in a windowless box, you literally stay stressed for longer.
Your cortisol lingers because your body feels trapped. And this leads us to the mental health stats, which were, frankly, they were alarming. The survey of over 14,000 Thai university students painted a bleak picture.
Yeah, these numbers were heavy. 31% of students experienced depressive symptoms, and over 14% met the criteria for major depressive disorder.
That's nearly a third of the student population struggling. And the risk factors line up with our discussion. Vulnerable groups included those living alone, those with high academic stress.
People likely isolating themselves indoors.
Precisely. And the sources brought up a concept I'd never heard of before, summer SAD.
Right. I always think of seasonal affective disorder as a winter thing,
Yeah.
Darkness, gloom, snow.
The classic winter blues. But in hot climates, or even for us during a really intense heat wave, you can get summer SAD. People retreat into dark air-conditioned rooms to escape the heat. They pull the blinds down.
So they create an artificial winter for their own bodies.
You do. It's blazing hot and sunny outside, but your body thinks it's midwinter. Because you've been hiding in the dark at 68 degrees all day, your circadian rhythm just crashes.
Okay, so we've established the problem. We are solar-powered machines hiding in caves. Let's get to the fix. The sources call it the protocol, and I want to be specific because I know people will try to cheat this.
We all look for the shortcut.
So, step 1 is timing. When do we need to see the sun?
The critical window is the morning. The research suggests you need that bright light within 30 to 60 minutes of waking up.
Okay, 30 to 60 minutes. Get coffee, go outside. How long do I have to stand there for?
It's a sliding scale based on the weather. If it's a clear, sunny day, 5 minutes is often enough to trigger the SCN.
5 minutes, that's nothing.
Very doable. If it's cloudy, you bump it to 10 minutes. And if it's really overcast or raining, you probably need 20 to 30 minutes.
Wait, it still works if it's raining. It feels so dark out when it rains.
It feels dark relative to a sunny day, but it is still exponentially brighter than your indoor lights. Your kitchen lights might be 500 lux. A rainy day is still thousands of lux. Your IPRGCs will notice the difference.
Okay, now for the cheating question. I drive to work. Can I just leave the sunglasses off and look through the windshield? Or sit by a nice big window?
I am so sorry to tell you this, but absolutely not. The sources are strict on the no window rule.
But why? It's transparent. I can see through it. Why can't the light get in?
You can see the visible image, but modern glass is engineered to filter UV and scatter light. It blocks the specific wavelengths for vitamin D almost entirely, and it scatters the blue light enough that it just doesn't hit your SCN with the intensity it needs.
So looking through a window is like eating the wrapper but not the candy bar.
Effectively, yes. You need direct photon-to-retina contact. Prescription glasses are fine, but you have to physically open the door or the window.
Okay, fine. But we have to talk about safety again. If I'm in Thailand or Texas in July and I go out for 30 minutes, I'm gonna get roasted.
And this is where the nuance is so important. We aren't suggesting you go sunbathing at noon. The sources emphasize a golden time.
Which is when?
Early morning, say 6:00 to 9:00 a.m., or late afternoon after 4:00 p.m. At these times, the solar angle is low. You get the light intensity for your eyes, but the UV radiation that burns your skin is much, much lower.
Catch the sunrise, not the sunburn.
Exactly. And for vitamin D, you really don't need much. For fair-skinned individuals, 5 to 15 minutes a few times a week is often enough.
Okay. There was one last part of the protocol that actually scared me a little. It wasn't about getting more light, it was about the dangers of light at the wrong time.
Yes, the anti-sun effect. This involves a specific neural pathway called the perihabenular pathway.
That sounds ominous. What is that?
It's a circuit that seems to be uniquely sensitive to light at night. The research suggests that hitting this pathway with bright light between, say, 10:00 p.m. and 4:20 a.m. can actively trigger depression-linked signals.
So bright light in the morning is an antidepressant, but bright light in the middle of the night is a depressant.
That appears to be the case. When you're lying in bed at midnight scrolling on your phone with the brightness all the way up, you aren't just ruining your sleep, you might be flipping a depression switch in your brain.
We really have completely inverted our natural environment, haven't we? We live in dim caves during the day and stare into supernovas at night.
We have confused our biology entirely, and the result is this urban hibernation and the mental health decline we're seeing in the data.
It's a lot to take in. We've gone from the molecular level as little factory managers making serotonin all the way to these massive cultural forces keeping us indoors. It really changes how I look at my daily routine.
It should. And I think the biggest takeaway here is to stop viewing light as just a utility. We think of light as just, can I see what I'm doing?
Right. It's a tool to help us work or read.
But if we shift our perspective and treat light as nutrition, as a nutrient that your brain physically requires to function, it changes everything.
The light as nutrition. I like that.
It forces us to ask bigger questions. If light is a nutrient, are our schools malnourishing our children by keeping them in windowless rooms? Are our offices making us sick by design?
We might look back at the cubicle era the same way we look back at smoking on airplanes. Just a terrible idea that we all accepted for way too long.
I think that's very likely. We are starving for light in a world that is brighter than ever, just with all the wrong kinds of light.
Well, on that note, I think I have a prescription to fill. I'm gonna go step outside and find a patch of sky.
A wise choice. Just remember to leave the sunglasses inside for a few minutes.
Thank you all for listening to this deep dive. Hopefully it sheds some light, pun intended, on why you might be feeling a little wilted.
Treat yourself like the complex houseplant you are.
Go touch some grass, everyone. We'll catch you next time.